Okay, so I want to compare the difference between Mesopotamian math and Chinese math. And so I chose two problems to illustrate a big difference, which is the base system. So we're going to look for the Mesopotamian problem. We're going to look at chapter 1, number 13. And the problem is you're trying to find the reciprocal of 18. And the reciprocal in ancient Mesopotamian math is a number that will multiply by this number and equal 1 for them. And 1 is 60. It's going to be 60 or 60 squared. 60 cubed, because they're in base 60. So first we go, 18 does not go into 60 evenly. Now we go 60 squared, which is 3600. 18 goes into 3600 200 times. Now 200 is our final answer, right? It would be our final answer in modern math. However, in ancient Mesopotamian math, they use base 60, as we said earlier. So you have to actually put it in multiples of 60. So it's going to be 3 times 60 plus 20, but the remainder is 20. So it's actually 3 comma 20 is our final answer. This is different than obvious notation in modern math because they use, again, base 60. And so now we're going to go over to Chinese math. And they're a system that actually does use base 10, which is still what we use today. And what that basically means is you've got, so we're going to find the square of 142,884. And so the base 10 will come into play because if you think about a square number, you can break it down to geometry, right? So we're just going to assume this is a 3-digit number. It is. I'm just going to tell you right now. But you can work with any number of digits. And so this is the hundredths digit, this is the tenths digit, and this is the ones digit. So we're going to represent C, B, A. Now A is going to be 100 times A, right? Because it's if this number was 355, it'd be A would represent 3, but it's really the hundreds. This is the tenths, this is the ones. So we can do 100A plus 10B plus C times 100A plus 10B plus C, and that'll equal our square number. So first we find A, we find the hundredths digit, and that's easy. We just guess a random number, A equals 3. That would be 300 by 300, which is this square right here, which would be 90,000. We don't know that's right, so we'll test the next one. A equals 4, that's 400 by 400, that's 160,000, which is more than 142,884, which is our final number. So it can't be 4 because 4 would be too much. So we know it's in the threes. Now we find B. We know that we do 142,884 minus 90,000, and we're gonna get 52884, which is going to be the area of our large gnomon. So that's the largest area of the largest square minus the smaller square. Now to find B, we know that these two rectangles here have to be less than the large gnomon. So one rectangle is going to be 100A by 10B. That's going to be, and wait, there's two of them. The A is 3, so this is going to be 6,000B. Has to be smaller than 52,884. We're going to get B is less than 8.814. So our preliminary thought is that B is equal to A. Now we have to test it and add in this little square. And so it's going to be 6,000 times 8 plus that little square, which is going to be 10B squared. And we're going to get 48 grand. And we're going to get 6,400, which is added together is 54,400, which is greater than the actual area of the large gnomon. So B is not our answer. We're gonna try B equals 7. I'm gonna plug in for you to save time. It's 42 plus 4,900. That's 46,900, which is less than our large gnomon. So B is actually, in fact, not 8 but 7. And now we're gonna try and find C. In C, we're going to do the same way. We know that this next area is going to be 52,884 minus 46,900. That is equal to 5,084. And then we know that has to be bigger then these two sliver of rectangles like before, and that would be C times 100A, sorry, getting messy, I'll put it down here, 100A plus 10B times C, and there's two of them, and that should be less than your 52,884 minus 46,900. And to save you time, I'm just going to tell you that we're going to get C is less than 8.08. So C, our best guess is going to be 8. So our new idea is 378, but again we have to test the last digit just like in the other ones. But we know that 8 times 8 is going to be 64, so it's going to result in a 4 in the last digit. If it were 7, it would end up in 9. If it were 6, it would end up in 6. If it was 5, it would end up in 5. And if we test out 378 times 378, we do in fact get 142,884. So this method isn't perfect because it's a trial and error. It does take more time, but you know, it's an interesting geometric way to figure out a square. And in relation to the other problem, we find interesting, you know, the base 60 versus base 100, or base 60 versus base 10. You know, that's a big difference between the two systems. Thank you.